This is the solution video for question 7 from paper 1 of the 2019 TMUA exam. In this question, we're asked to consider this curve y is equal to 2q minus x squared times 2qx plus 3, where q is some real number, parameter. And then we're asked to find the value of q which minimises the gradient of the curve at x equals minus 1. And for this we're given a few possible answers. We're given 7 in total, which are minus 1, minus 3 over 4, minus a half, 0, a half, 3/4, or 1. Now, to solve this, the first step is we're asked about the gradient of the curve, so let's get an expression for the gradient of the curve, i.e. dy by dx. So how do we differentiate this? Well, we've got a product of two things, and we know how to differentiate 2q minus x squared. We know how to differentiate 2qx plus 3, so it's time to use the product rule. So let's differentiate this to get minus 2x times the 2qx plus 3, and then vice versa, differentiate 2qx plus 3 to get 2q, so we get plus 2q times 2q minus x squared. Now, this is pretty horrible to work with, so let's tidy this up. So collect the x squared terms together. We've got minus 4q and then minus 2q, so minus 6qx squared, minus the 6x, and then plus 4q squared from here. So here's our expression for the gradient. So now let's focus in on what we actually need. We only actually care when x is minus 1. Because that's the value of x for which we have to minimise this gradient. So what does this look like when x is minus 1? Well, let's simply substitute it in, and we get minus 6q, because we get minus 1 squared here, minus 6, so plus 6, plus 4q squared. So this is the thing we now have to minimise with respect to q. So how do we do this? Well, you can probably see that this is a quadratic in q. And so we know the graph should look something like this. And we want to minimise this function as q varies. So how do we do that? Well, we need the point at which the gradient is 0, i.e. the turning point of this graph. And so we work that out by considering the derivative of this with respect to q. And we want it to be equal to 0, because that'll be our turning point, and then we just pluck our value of q out and we're done. So let's differentiate this, and we get minus 6 plus 8q is equal to 0, which you'll see rearranges to q is equal to 3 over 4 by adding 6 and dividing through by 8. And so this matches f on our answers, and so we know that f is our answer, and q equals 3 over 4 is the minimiser we require.